from this equation, right, carbon dioxide plus calcium oxide is going to make calcium carbonate. What would the Kc expression be for this one?
Let me think.
It would just be
One over
One.
KO2.
Okay.
There's no K, man. Enrique.
All right, that works. And then because everything is balanced, it is a 1-to-1-to-1 ratio. Again, thank you, Elizabeth, for that. You would do this. The reason I picked this one is because you might have a situation where the 1's at the top, then put the 1. If it's a 1 at the bottom, it's invisible. Also, solids, do they count?
No.
No, so we can get rid of this. Okay? Yes.
If you're using a 1 that's just by itself, like on the top to bottom, do we need to put brackets around that?
No, you do not, because it's just a 1. No, you do not have to. You do not have to. So this problem right here is kind of like phase 1. Phase 2 would be if I gave you a number for the concentration of CO. So let's say we have 0.33. Okay, then what do we do with this number?
You put it in where CO2 is.
Yeah, we put it right here, 0.33. And 1 divided by 0.33. Sorry, 1 divided by 0.33 is 3.03. So is this going to favor reactants or products if it's a big number?
Products.
Products. Okay? So this is going to favor products. Now again, kind of tricky, right? Because you would think if the number's a 1 and you plug in a number, you would assume that 1 divided by a number would be smaller than 1, right? Don't always assume that way, right? Because it is possible that you have a weak concentration, and 0.33 is pretty weak, but it's possible. So don't assume mathematically, okay? I have a lot of people assume, well, Mr. Taylor, it's a 0, it's a 1, invisible 1 at the bottom. It's going to favor reactants automatically. Now, if this is smaller than 1 to begin with, okay? So trust the math, okay? Don't just immediately jump to it. Do the math, and you'll be fine. This is phase 2.
Okay.
Are we okay for phase 3 now?
Yes.
Yeah.
Okay, phase 3, we need to talk about an ice diagram. Okay? Okay. I is initial, C is change, and E is equilibrium. What was that? Wait. Sorry, I spelled initial wrong. My bad. It's ITI, right?
Yeah.
Okay, I forgot the I in the middle. I'm sorry.
That's okay.
My bad. Almost embarrassed myself on the YouTubes. I already embarrassed myself on the YouTubes. You guys saw that, so some of you didn't see the video. The intro video I told Calgary to show you while you were getting your summer stuff.
Oh, I saw that.
Okay? Oh, I saw it. So,
My
with
favorite video on YouTube.
excellent. Excellent. Sweet. So, with this, what if it's not already at equilibrium? When you're doing the Kc expression, that works. That works. When I give you a number, that works. Because that's going to be the equilibrium concentration. But is there a possibility that I give you information about not equilibrium? Is it possible that there's a problem and we're still not there yet? So for example, remember the straw thing we did? Were you automatically at equilibrium or did you have to work for it? You had to work for it. Sometimes mathematically we need to work for it as well. So this is something that we can totally take advantage of. So here's what we're going to do. Okay? We're going to have a normal problem. Normal. Okay? Matter of fact, let's do this. H2O gas both ways. This will be a 2. This will be a 2 for H2. And a 1 for the O2. Both of these will be gases. Okay? Are we okay with that? Is there anything scary about this? No. Okay? What about this? I'm going to give you some concentrations initially. And we're trying to figure out what they're going to be at equilibrium, right? So we're not there yet. Okay? We're not there yet. Here's how to set it up. You're going to think of this like a math problem. Okay? So we're going to have a beginning, we're going to mess with it, and equilibrium is going to be at the end. Matter of fact, one of the other things that some people kind of teach is that the E stands for end. If that helps anybody, that's totally cool. Okay? But normally when I see it, it's initial change in equilibrium, which is the end. Okay, up to you. Here's what you do. We want this by itself. So we're going to kind of think of this as a math equation. What I do is I put a line right through the arrow. And again, how I'm doing this is a little different than what like my professors did, what my AP Chem teacher did. But honestly, like people have told me this is nice, so I'm going to keep going with that. Okay. I don't like doing. There's a way with boxes, but I think this will be a little bit easier to draw. So let's say that we have an initial concentration. Okay. So Abraham, let's pick a concentration for some water. Yeah, just like any number really.
4.
4, sure. We have 4 molar water. Okay, maybe not the best example, but it'll work. Okay? Because water's water. Kind of tough. Well, at the beginning, this is kind of a new thing, right? At the beginning of this process, at the very beginning, when you just have water vapor, is there any oxygen and is there any water? At the very beginning. No. So guess what we get to put for the initial concentrations? If there is none,
Zero.
there's zeros. That's the first new thing. And again, I know the water maybe isn't that good of an example for this because obviously water is water. It's not really a concentration, but we'll play with it. Now we're definitely going to talk about what you mentioned yesterday. That's definitely coming up in a little bit. Just to give you a heads up because I'm going to have you pick. How are we doing so far?
So the numbers on the other side of so on the product side, it just depends on the compound or the first element on the product side?
Yes. And actually, you know, I know since I'm talking to you right now, I'll mention it now. Jasmine, is this reaction going forward or backwards? Primarily. Is this one favoring the products or reactants? You can tell from this information on the board.
And the product? I mean the reactants? Which one?
Is it going to make products or is it going to make reactants? That's a good question, isn't it? So Jasmine, I'm going to ask it this way. Jasmine, does this arrow make sense?
No.
Why? Jasmine, can you make me a pizza right now? Right now. Like right now, where you are. Can you make me a pizza?
No.
No, why not?
Because I don't have the ingredients.
Excellent. Do you have any H2 or O2? Do you have any ingredients right now?
Yes.
Do you? What numbers did we write for the concentrations?
Oh, no.
No. Do you have any H2 or O2?
No.
No, we don't. So can you make water if you have nothing to make the water with?
No.
No. So is this reaction going backwards? No. This reaction has to go forward. So the arrow needs to be flipped. Yes?
How'd you get to 0?
Excellent. We got to zeros because we decided for this problem that we were going to go this way. So essentially we picked our initial concentration for water because we have water at the beginning, at the very beginning. Before this starts breaking down, are there any products at the very, 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 very beginning?
No.
No. If I gave you a thing of bread, boom, like a loaf. And if I gave you some cheese, you could make real cheese, right? You could. But do you have any at the beginning? No, same thing. You have all the ingredients in the world to do it, but you haven't made any yet. So that's why the zeros are with the H2 and O2. We haven't made any yet, initially. We're going to get to the point where it does at the bottom. Does that answer the question? That's a good question. Yeah, how? Now again, if this problem was going backwards, the 0 would be by the H2O. Because there's no H2O at the beginning then. This thing's going to want to go backwards. Is that okay? Cool. So, that's the first part, and that's it. For the change, how do we know what the change is? Do we know the change?
No.
No, we don't. Do you know how much this is going to change? Do any of us know? What do we normally put if we don't know and we're trying to figure it out?
Question marks.
Or
X.
Nothing.
an X. Yeah, we're going for an X. And a matter of fact, let's be real about something. Is this going to go up or down as we go this way?
Down.
So we would put negative X. But how much X? How many X's?
2.
2. Whatever that change is, it's going to be magnified because the coefficient is 2.
Wait, Mr. So it's negative because in the product side there's nothing?
Yes, and we're going to be making this. And to make this, don't we need to lose that? Yeah. And there you go. So if you're going this way, this stuff's going to go up, right? So is it cool if I just put the pluses right now? That stuff's going to go up. That stuff's going to go up. What factor is this going to go up, though?
2.
2,
X.
X,
1x.
and 1X. And again, the reason why this side is plus is because we're going that way. We are making that stuff. And again, this is new. Okay, this is new. I know it goes 1 and 2 are pretty chill, and I know it jumps right to 3. I get it. How we doing? Are there any questions? Okay. We ready for the E part?
Yeah.
Cool. All right, so E, 4 minus 2x. 4 minus 2x.
Oh.
That's it.
Initially.
0 plus 2x. Can I just write 2x? 0 plus x is x.
So this is what we combine.
Yeah. Well, and when you say both, these both.
Yeah.
Not these both. Just to make sure that's clear for everybody else. These, yes. And remember, I'm going to put a plus there too. All right, cool.
So initial and change combined.
Yeah, for equilibrium. Because whatever happens here, plus the manipulation of the change, right, up or down, that's going to be what you have at the end. Now again, here's the cool part. With x, this is all AP Chem. Okay, this is college chem right here. I am not that concerned about us solving for x.
Yeah.
Okay? But we do need to be able to put this together. Because right now, does this mean anything? Not really. But here's what we can do. Kc, as you know, is going to be H2 squared. O2 to the first divided by H2O squared. Are we okay with that? And again, everything's gas, so it counts. Are we okay with that? All good? And we just plug everything in. So, the H2 part is 2x. The O2 part is x. What's the bottom part?
4 minus 2 squared. I mean,
4 minus 2x
squared.
squared. And ladies and gentlemen, that's the answer. If I wanted to find the Kc value for this equation, I could set up this equation and go from there. Bless you. And you're good. Yes?
for the 4 value for 2H2O on the reactive side,
Mhm.
is there a specific reason why we got 4?
I believe it was Abraham said 4.
Oh, okay. So just like,
Yeah, and then the problem, I would tell you, hey, the initial concentration is 3.5.
oh, okay.
So from that aspect, that would be given to you. You would know the problem, absolutely.
And then in the product side, would that always be 0? Or?
That's the next one. It might not always be 0.
Okay.
Bless you. Are you good?
I'm fine.
Sneezing fit? I would give you tissues if I had any, but they get stolen all the time.
So is that how we would leave our final answer?
That
We're
for...
just setting up the equation?
Yes,
or are we
we're just
doing-
setting up the equation. We will talk a little bit about solving for x tomorrow.
So we will eventually solve it.
Yes, and it will not be crazy, okay, because we can solve for x. But right now we're just worrying about the ice diagram. Today's about the ice diagram. Tomorrow's about x.
Okay.
Yeah. So we're gonna do another one. Are there any questions on this one before I do another one? Are we okay?
Yeah.
Again, it's a total. I know this is like 0 to 60. Are we good?
Yeah.
Swag in a bag, loose on a goose. All right, cool. So, I'm looking at this piece of paper right now because I have a really good one, and I would like to get that for you. We can talk a little bit more about it. Okay? Let's do this one. I have a really nice one for us. I think we've done this one before, actually. Oh, wait. Yep. Okay. So, we have this, and let us talk about that, okay? So, again, I'm going to say something about like the equilibrium concentrations aren't being reached. It's got some initial to it. That should be an E. That should be an E.
Don't you just delete the first one?
Yes. Does the first one count at all?
No.
No. So here's what I want to do. I normally put a whole line through it, and I just put a squiggle. And I do a squiggle to make it a little bit different than this. I mean, I'm sure you find just doing a squiggle, but I normally do it differently than this, so it just stands out to me a little bit more. But yeah, that's out. So with this new thing, this ice diagram, the solids and liquids also don't count. Okay? So we did one that, yeah, we'll do a forward. We'll do a forward one again. For sure. For sure, for sure, for sure, for sure. Just checking a few things. Just checking a few things. Yeah, for sure, for sure. Nice. Okay, cool. So let's say that our initial concentration for O2 is, you know what? Here, you know what? Let's do it over here. This will be 0.2. Is that okay?
Yeah.
We're going to do this. So I'm going to say initially there's a 0.2 concentration of FeO3. Cool. And let's say that the initial concentration of oxygen is 0. Is this reaction going backwards or forwards?
Backwards.
Backwards.
Backwards. Right, have we made any of this yet? No. So we're going this way now.
For sure.
Yes.
Is there always going to be zeros in the initial?
No. It is possible that you have a little bit of everything at the beginning, and what's it going to do from there? The cool thing is from that, you treat it the same. But I would have to provide you more info about the arrow. Because what this arrow tells you, this arrow tells you what side the pluses and minuses are going to be on. So in this case, right, first off, are you going to gain or lose if it's a 0?
Yeah.
Only gain, right? So you're going to gain 3x. And what are you going to do with the other one?
Lose.
Lose. I heard the x. How many number? How many
2x.
x's? 2x. And again, I'm pulling that straight from the coefficients. It's going to be magnified, right? If I have 3 moles of it, it's going to be magnified by 3. Each change, XXX. So doing this extension, this one will be 3x. This one is 0.2 minus 2x. I know I just went a lot faster on that one. How are we doing?
Yep.
So again, the reason that 0 is telling us that this is only going to go up. You can't have a negative concentration. That's not a thing. So it has to only go up. That's why the plus is. And if this is going up, the products have to be going down. Ooh, if we knew the x value, we could start doing that, but we don't. And then Kc value here, right? We'll go at the top.
It'll be
What's the product?
point
FeO3.
minus.
Yeah, FeO3 is a product. Oh, I'm just setting it up first. I'm sorry. You guys were plugging in numbers, right? I'm sorry. I was just setting it up first. What's how many FeO3s are there? 2. And then this O2 cubed is at the bottom. The cool thing about this is if the reaction is written this way, this is how you would write it. So I know it's flipping. Are you guys thinking these are the new products now?
Yeah.
Was that happening? Because it's written this way, you don't have to worry about that. Okay, this is still the product as written. If it was written the other way, I would have flipped it. So you're totally okay saying that's the product still.
So regardless where the arrow is pointing, it's always going to be like plugged in this way.
Yes. Yep. And again, part of this is there are harder problems. There's an extension of this, but again, we're worrying about the basics right now. I know they might not sound crazy because we're talking about AP basics, but this is fine. So this is still the products. And then you would just plug it in. So in this case, the Fe2O3, 0.2 minus 2x squared, 3x cubed, and that is your answer.